So I don't have slides. The idea is I want to detoxicate from making slides. I'm making too many. So it's more discussion and a demo, especially that's about the tool. So please interrupt myself whenever you want, whenever it's not unclear. We have 15 minutes together. So Fink. So before I start going into the tool, I want to clarify a bit. We talk a lot about broker, the word broker itself, but it can mean very different things depending on the context. So here I talk in the context of large-scale survey. So those big telescopes that survey the sky and send millions of alerts every night. So that's scary. So yesterday, Louise, I think, sketched a bit through Atlas. The idea is always the same. You make observation at a given time t, and you compare to observation made in the past to make a difference. And if there is something left in the difference, you call that an alert. If it's above a certain threshold, and you send that to the community for further inspection. The idea is very, very basic, very simple. Of course, you can open an alert. What you have usually are facts like magnitude, position, time. So you can see an evolution, for example, of the light curve over time. That's nice, but of course, the problem is the number of alerts that you can really read every night. For a given human, well, a dozen, maybe 100 on good nights, but not much. The problem is the telescope are sending all the surveys, well, up to 1 million, several million for Rabin are expected per night. And the question was, what should we do? And brokers came in. Of course, brokers were there for a long time in the landscape, but they had a very new role here, which was not only disseminating information, but also filtering information so that you, as a user, you get only what you get interested in and not all the noise that can come from the sky. And this is where Fink comes from, basically. So Fink was created in response to LSST call to this broker ecosystem. So they had this 10 million alerts per night, and we had to do something. We came up with some plan. So there are many brokers in LSST, as you know. I'm super happy because in this workshop only Fink responded. So forget about the others. So they are all great. We are just better.
Forget, and then laser as well. So
well, but you didn't talk about laser.
no, I didn't.
See, you're ashamed, right? No, I'm joking.
This is being recorded, right?
That was easy, sorry. No, they are nice. So they are all very different specificity. I will talk about Fink. Of course, we share common things as well. You can wonder why there are many brokers and not only one. I have a few answers for you, but I won't answer now. So Fink. So the idea is the following. The stream is coming, and the question is, among these 10 million, can I get only the few of interest every night? Question is, what's the few of interest for you or for you or for you? That can be different. So first of all, we wanted flexibility. So we didn't want to focus on a particular scientific topic that could have been supernova type 1a, but no, we don't want to restrict only to that. So we wanted flexibility. So in Fink, we try to do as many science cases as possible. That's the first thing. And the second thing, it should be usable, because if I come with a bunch of script, I'm an engineer, so I love it, but I guess you're a scientist, so you just want to click buttons and get the results. So we need to have something flexible and not use like a supercomputer or the cloud to get finally just a light curve. So we had that in mind 5 years ago when we started. And here's Fink. So this is the single entry point for everything you can get about Fink. This is fink-broker.org, this URL. You can bookmark it. It's very useful. There are many things. There are news, not very populated, so you can forget about it. What's interesting is documentation. Here you will get a lot of information. I will go through in a minute. Some information about publication made by Fink members. So here a disclaimer. So Fink is not like a bunch of, it's not like an official team like, I don't know, LSST or Dark Energy Sense Collaboration. It's more like there is a tool, and around this tool, people gravitate. They can come, they can leave, they can use the data without even telling us, although they do, they tell us. And usually it leads to publication. So the scientific team, they are on their own, okay? We just provide a service to the community, and I will come back to this notion of service. So I'm not here to say, do this science or do that science, or I don't want this science. I'm here to provide service so that the science you want to do can be done. So it's a publication related to people that communicate with us. Team, also people that declare that they are super happy with us and they want their name to be on it. But the first thing is probably where you will find a lot of information is in the documentation. So if you click on the documentation, you will end up in this page. There are many different things. On the left, you have a bar, you have a menu with different things. It starts first with a section describing what is Fink. So here first you have a few, the question you get straight, like what is Fink, what Fink does, who is behind Fink, etc., etc. Hopefully you will get some information plus link to other things. Then you have some information about science roadmap. So if you click, you can see it's long list, not exhaustive. I'll try to do as many things as you want. That's the purpose. So Fink, as I said, is connected to large-scale survey. Of course, when it was created a few years ago, it was with LSST in mind, but LSST was far to be starting. So we had to play with something, and hopefully ZTF, the Zwicky-Tron facility, gave us access to their stream. So we are analyzing their stream for now 5 years. We're also connecting to high energy data streams like GCN, as we heard about before. And of course, we use virtually anything that exists, catalogs, external databases, as long as someone has the need for it. Okay, we don't add things just for adding things, but if someone needs something, it's easy to plug in. And I will go through the different things that we have so far. And the idea is we take those three things, we massage them inside Fink, and at the output of Fink, you have basically a list of alerts tagged with tags. Like this is probably a solar system alert. This is probably a supernova. This is probably blue. But this is based on the massage that are done here. And the massage, they are done by you. Okay? Me, I'm an expert in neither solar system, nor variable stars, nor supernova. I don't know anything. So eventually, there are clever people that comes and that create science modules in Fink. Science modules, in a nutshell, they are based on the Python language, and they take in as input alerts or external data, sorry. And on the output, they can give a score if it's a machine learning model. They can give a tag. They can give any contextual information that will enrich the original content of the alert. And we have many of those science modules. If you click, that's the idea. Yeah, as input, you have position, flux, time, whatever. Science module number 1, 2, 3, 4, 5, you have more than a dozen now. And on the output, you have the scores, the flag, the labels, anything. So we gather all kind of information based on whatever the community is interested in. And we do that in real time for those million of alerts every night. So we have things related to cross-match. So this is where the catalogs and the databases are coming through. So we cross-match with a lot of things, like we use the CDS, Centre de Données à Strasbourg, Astronomique, which hosts the SIMBA database. So cross-match automatically with that. We use GCVS, the General Catalog of Variable Stars. We have VSX for variable stars. We have Gaia, there are 3. We have the 4LAC and the 3HSP also for blazars, for example. 2 minutes already. 2 minutes? No, 20 minutes. Then you have things like machine learning, deep learning related things, supernova, kilonova, microlensing. You have broad class classifiers as well, anomaly scores for anomaly detection, and you have things like standard modules that focus that are not as fancy as machine learning, but that does some processing for asteroids, for example, or multi-messenger astronomy. And once you have all this information, including the original content plus the added value, you can build what's called filters. And filters, they are just recipe where you say, now I want alert with that tag or with that value above this threshold, etc. So you build your own filter based on whatever you want, and you get only the substring out of this filter. And that's how it works in practice. So we have, now the question is how you get the alert in 1 minute. So we have many services that are based on the need of the community. You have a service called the live stream if you want to get the data as soon as it gets processed. So this is based on Kafka, and we have a client, so you can get it. It's used for the follow-up, for example. Or you can use the web-based interface, or it's REST API, of course, that is behind the hood. This is probably the most used service. If you go on the web, fink-portal.org, you get this bar in like 30 seconds. It's a sort of smart bar, so you start typing and it tries to recognize what you are trying to do. But you can do cone search by name. You can search, if you know ZTF name, but nobody knows, but you can paste it. You can search by astronomical name as well. You will, so I don't know, coma, cluster. It will eventually find something. Yeah, it is, and you will perform a cone search. You can search by class as well, so all the tags that Fink provide, and that will be the last thing. Class. You will have a drop-down, and you can search for anything. If you're unsure, for example, I don't know, low mass X-ray binary. Yeah, we have a bunch. You hit enter, and eventually it will give you the latest 100 objects found. Yeah, here it is. So you will have a preview of those objects. And nothing, you can open an object eventually and dig, and you have a lot of information. And I stop here because I'm very late, sorry.